All right, cool. So yeah, we're gonna upload this to YouTube. That way, for the people that aren't here, they can watch it, and you can go back and watch it if you want. Leave comments, like, and subscribe, of course. Oh yeah, I should also show my face. Hello, I'm here. 8.5, 8.5 probability independent events. So we've been talking about the probs, right? Up until now, we've been talking about things that aren't dependent for the most part, right? We've been talking about like coin flips. So if I flip a coin and I get heads, that has nothing to do with if I flip it again, will I get heads, right? The odds will stay the same, right? It doesn't change. So what we're talking about now are dependent events, which we kind of talked about a little bit, right? This first one should sound familiar. 2 cards, 2, are dealt from a standard deck of 52 cards. What is the probability that the first card is a diamond and the second card is a spade? Now, you might be tempted to think that this is what's happening. That we're going to get a 1 out of 4 chance for the diamond, right? Because there are 4 suits, 1 out of 4, right? And we're going to get a 1 out of 4 chance for the spade. If you multiply them together, you get 1 out of 16. But this is not true. Because when you draw a card for the first one, right, you are changing the odds for the second. Does that make sense? Right? When I draw initially, 13 out of the 52 cards, which is a quarter, right, could be a diamond. But even if I don't draw a diamond, if I draw just any card, the odds of getting a spade for the second one is not 13 out of 52, right? So imagine I get my diamond, right? That's 13 out of 52, right? But after I take that diamond out, there are no longer 52 cards in the deck. How many cards we got?
51.
51 all day. Now, Conway would ask this question. Wait a minute. What if I didn't draw a spade here? What if I drew a diamond here? Wouldn't that change things the other way around and all kinds of stuff? Yes. But what we're doing is we're calculating what are the odds that I do get a diamond and then I do get a spade, right? So assuming I get a diamond, it was a 13 out of 52 chance, which would then change our odds of getting a spade to 13 out of 51, right? So altogether, we get 13 squared over 52 times 51. Those are our odds, which, by the way, would be the same as saying, you know, I have a, what is it? It's, what am I thinking? If we were to just simply count, like, there would be 52 ways for the first one, right, that we could draw, and 51 ways for the next one. And then, like, what I would get is, like, there are 13, there'd be 13 options here of ways to do it. So I'd also have 13 here and then 13 there, which is literally what we just did here, right? I'd have 52 options for the first one, then I have 52 options for my second draw. That's what that is, right? And I have 13 and 13 for both of these. So just by counting, we can get there. What I'm going to do is give you a similar problem that's not quite like that. So let's take a look at what I'm looking at. 814. A bag has 4 red and 6 blue marbles. If we take a marble out but don't put it back, right? So it's kind of like drawing cards out of the deck, right? We're not putting it back. And we draw a second. What is the probability that they're both the same color? So we have casework here. We want to know when they're both the same color, right? So what's the first case? Give me the first case.
2 red.
2 red, right? So I'm going to write that down. So we have case 1. We're going to call that both red, right? And then, of course, we're going to have case 2, which is what? Double blue. Both marbles are blue. Not ball marbles. Where am I thinking? That was thinking it. All right.
Surprisingly not, actually.
So, 4 red, 6 blue is what we got going on here. So, total bag, let me write that at the top. 4 red, 6 blue. All right, cool. So, the odds of getting our first red is what out of what? What are the odds of getting the first red out of the bag?
4 out of 10?
4 out of 10 all day, right? Which simplifies, but I like 4 out of 10 better. It's clear where you got your numbers, right? 4 out of its possible 10. Then when we draw the second one, right? For both of them to happen at the same time, right? We do times, right? Because that's going to shrink the odds of it happening, because it's rare to get 2 reds in a row, right? The second time, there are only 3 reds left in the bag. But it's not 3 out of 10, it's 3 out of what?
9.
All day long. So we get 12 out of 90. And I'll just leave that there, right? So not super likely, right? 12 out of 90. It's more than 10%, but it's not super likely. Then we have the other case, right? Both are blue. So we still have 10 marbles, and then we'll have 9 marbles because we're going to take one out, right? But our odds of getting blue are going to be 6 for the first one, 6 out of 10, and 5 out of 9 for the next one. So we get 30 out of 90, which is much more likely, right? It's a 30% chance of happening. 33%, right? 1 out of 3. So together, because these are both cases, right? We're going to add these two. And I think that's really important to understand about why we're doing that. We're multiplying these here because the odds of it happening twice in a row shrinks, right? If you want to flip heads 5 times in a row, that's going to be a half times itself 5 times, right? Because the odds of getting heads 5 times in a row get smaller every time you try to do it again, right? Like 6 times is going to be more rare than 5 times. So you're multiplying, and when you multiply fractions, they get smaller, right? But if we want to know the odds of drawing either double red or double blue, well, if the odds of just drawing double red would be this, right? But if I'm also allowed to get blue, right? Well, then my odds just went up, right? Because I can now do all the double reds, but I could also do all the double blues, right? So my odds are going to go up. I'm going to add those so that they don't shrink, but instead, the odds go up, right? The more options I have to win, the higher the odds will be. So if it was just double red, my odds would be this. And if it was just double blue, my odds would be this. But together, we're going to add, right? It's going to go up by that amount. 42 out of 90 are winning scenarios, which is just under half, by the way, for this particular problem. How are we feeling about multiplying, like, simultaneous events and adding cases? How do we feel about that? Cool? All right. And we see these are dependent. Yeah. They're dependent events because the first event affects the second, right? Because if I take one marble out, now there are less, right? That's the idea. They depend on each other. It's not like a coin flip where, like, if I get heads the first time, it's like, oh, well, there's 1 less heads I can get. No, there's still the same amount of heads you can get, 1 out of 2, right? All right, so let's look at this last one. Actually, no, I think that was it, actually. Told you it was a short one. So what we're going to do is we're going to take a look at some exercises now at the end of the section. And I'm going to give you an answer key for that, and you guys can ask questions if you got them. Otherwise, we'll get you out of here. Here's what I'm looking at. This is exercise 851, so chapter 8, section 5, exercise 1. Let's just do this one together, and then what I'll do is I'll write out an answer key and post it on Classroom like I would normally put on the board. That way you guys can check this stuff out and post it. Scooter especially, make sure you're uploading the stuff you do, bud. Okay, I want to give you credit for it, okay? So this will be your submission for Friday, right? One of the things that you can do. So we got 851. I'm going to write it down where you can't see it, and then I'll read it, and we'll switch over. So it says 2 cards, dealt at random from second deck 52, so it's kind of like the first one we did. Uh-oh, there I am. What is the probability that A, the first card is a heart, and the second is a club? So what is the odd that I get the first one a heart?
1 out of 13.
1 out of 13. Well,
13 out of
52,
13,
1 quarter, right?
I don't know why I said it that way.
No, it's all good. 13 out of 52. Now, this is literally the first problem, right? They just switch diamonds, right? The next one will be 13 out of 51 because there's 1 less card in the deck. But of course, diamonds are different than, or hearts are different than spades. Or not spades, clubs, right? So boom, there we go. 13 squared over 52 times 51. Done. Part B. All right, I'll read it out loud. What are the odds that the first card is a 6 and the second card is a queen? So I think you guys know by now that it's going to be 52 and 51, right? Because after we draw that 6, there's 51 cards left in the deck. So what are my odds of getting a 6? How many 6s are there in a deck?
4.
4. Now, when I draw that 6 out, does that mean there are somehow less queens? No. So I'll still have 4 queens. So we're going to get 16 out of this number. Whatever that is. Probably a good number to have memorized. That way you can do quick calculations in your head for poker, right? 52 times 51. All right, part C. What are the odds that the first card's a king and the second is a heart? How many kings we got in the deck?
4.
4 kings. 1 less card in the deck. How many hearts do we have now?
when we're doing this, are we like also subtracting what we've already done previously? Or
We're
is it
not.
just like
We're not putting the card back.
okay?
So
Well,
if
I mean,
I've
for, like-
drawn, what's up?
I mean, okay. I'm just gonna shut up and let you talk. Real quick.
No. Go ahead. What are you saying?
Since we're on problem C of this, would it still be?
Oh, okay. No.
correlating to, like, problem A?
Totally new
That's what I
scenario. Great question.
what I thought.
Great question. Yeah, because that would have affected this. Yeah.
Yeah, definitely.
I get what you're saying. Yeah. So now it's just what are the odds of getting king? And for the first card, second card's gonna be a heart. Now this is a little tricky because we drew a king, right? That's a 4 out of 52 chance. There are 51 cards left in the deck. What are the odds of getting a heart now? What out of 51?
Well, the king could have been a heart.
It could have
We
been.
don't know.
So we have cases, right? So case 1, king is a heart, right? There's our little heart. So if a king is a heart, then we had a 4 out of 52, right? Or let's just pause. That's going to be this guy, right? This is our different cases. So case 1 is king is a heart. So now how many hearts are left in the deck?
12.
12. So 12 out of 51 is the number that goes there, right? Now, case 2.
Mr. Mac, I can't draw a heart. This is very. I just do the little emoticon that all the
The emoji.
girls like. Yeah.
If you color it in after you do like the little, swiggle at the top, do one of these and then a V, right? You can
Wait,
kind of like
hold on.
round it out, squiggle at the top and then a V, right? You can kind of round it out a little bit.
Okay, that look. I did one that looked stupid as hell. Hold on, I
Oh,
gotta
you're
answer
good.
this.
Oh God, I'm making it worse. Yeah, you can kind of round it out a little bit and accentuate the top part. That's how I get away with it. But anyway,
I just stay doing. You even see it? The little less than in the 3.
oh right, so you're doing it sideways. Oh, I get you now. Like literally the emoticon, not like an emoji.
Yeah.
Got it. Okay, yeah, I respect that. So the other option is that king, not a heart, right? Not a heart. So if the king wasn't a heart, there's still 51 cards in the deck, but now we have 13 out of 12. So for this one, we have 4 out of 52 ways for the first. And then we're either going to multiply by this or this depending on the scenario, right? So I think what we need to do is think this way. Let's think about, instead of 4 out of 52, which represents the odds of getting a king, we'll say if the king is a heart, that means we had this. Let me write it over here. Times 1 out of 52. You see what I'm saying? Right? 1 out of 52 ways to get the king of hearts. And since we drew a king of hearts, there's only 12 hearts left, right? So that's going to be 12 over 52 times 51. And then we're going to add that with whatever we get here. Does that make sense? Right? So now if the king wasn't a heart, we have a 3 out of 52 chance to get a king, right? Because no hearts, right? We're not allowed to draw a heart. So it's got to be 3 out of 52. And then because we didn't draw the king of hearts, there's still 13 hearts left over. So it looks like 39 out of 52 times 51. And if we add those up, we're going to get a kami denami of 52 out of 51, or times 51 in the bottom, right? And then 12 plus 39 is 40 plus 11, which is 51. So that's kind of fun. We can actually divide these out because they're both 51s. We get a 1 out of 52 chance.
52 times 51 is 2,652.
2,000.
I'm gonna remember that.
2652. For this one, it actually helped not knowing it.
That's big.
This one helped not knowing because if you notice, after we had 12 and 39, we get 51. 51s divide out. So it's a 1 out of 52 chance for that happening. So getting a king first, and then the second card is a heart, is a 1 out of 52 chance. That's kind of fun. All right. So again, breaking it down into casework, right? King is a heart, affects both, right? King is not a heart, affects both. So you got to think outside the box here. Last one, part D. And then we'll let you guys go. I'll write an answer key for all this, uploaded online, blah, blah, blah. So what are the odds that the first one is a diamond? So first one, diamond. And then second card is an ace. So you'll notice it's similar to last one, right? because we draw an ace of diamonds here, that means we have less diamonds before. This is kind of like Josh's favorite day right here, because he was constantly asking questions like that, like, you know, but if this team wins the tournament later on, it'll affect, it's like, yeah, here we are. So different cases. Case 1. So what's the first case? All right, we're trying to figure out. Say again?
You pull an ace that is a diamond.
So ace is diamond. So ace of diamonds is what we get in the first pull. So that means it's a 1 out of 52 chance to get the ace of diamonds, right? And because we pulled a card out, there are only 51 left over. How many diamonds do we have left in the deck? We just pulled one of them.
So it'd be 12? Yeah.
All day. Cool. So that's our odds with ace being a diamond being drawn first, right? Case 2 is, well, ace of not diamonds, right? So not, I guess I can do this symbol, mathematical symbol, not diamonds, right? So if it's not a diamond, we have a 3 out of 52 chance. And then a 13 out of 51 chance. So it's like 39 out of, what was Scott's number? Scott, what's the number? What's 52 times 51?
2652.
2652. So looks like we're going to get in total here 51 out of 5251, which should be the exact same thing we got last time, right? Because all we did is just switch. Instead of an ace, it was a king, right? Instead of a diamond, it was a heart or whatever, right? So it's going to be the same odds. We get 1 out of 52. So it's the same odds as being like, I'm not good at magic, but here's a deck of cards, and you like pick a card randomly, and then I'm like, okay, I'm gonna guess your card randomly, right? I have a 1 out of 52 chance. So not very high, right? It's basically like just faking magic. Cool. So that's 851. I'll post answer keys online for 852, etc. Remember, the further you go, like, part A was nothing, right? But by the time we got to part C and part D was a little bit more advanced, right? So don't get discouraged if you're like on problem 2 or problem 3 or something, and you're like, you know, getting to part C and you're like, I don't know it. Well, cool, great. Move on to the next question, right? Because it's going to get easier again, right? It takes it further for each question. So don't get discouraged. Do as much as you can. Remember, that's the idea. Submit as much as you can. Use the answer key to try to figure things out. And then when you get that solutions manual, go back next week, hit them again, see if you can figure it out, right? Cool. So how are we feeling about dependent events, right? One influencing the other, right? Little casework. Good? Rad? Awesome. I'm going to write out an answer key. You guys can head out now if you don't have any questions, and I'll post that on Classroom. I'll put the link to this video there too. That way your friends can watch it, all right? Later.
Bye.
Bye-bye.
Bye-bye, King.
Bye.